Hey guys, this is Mr. Grice for Algebra 1, Chapter 9.4 Notes. Today we're talking about the GCF, or known as the greatest common factor. Our learning target today is to be able to find the greatest common factor of two or more monomials. Now, a couple things you need to know first is some vocabulary. So the first thing we're going to be talking about is the word factor. Now, factor means to write an expression as the product of two or more other expressions. And the greatest common factor, which you guys probably have heard most as the GCF, is the biggest factor that two or more expressions have in common. Okay, so the first thing we need to do is to find the factors of the following monomials, then find the greatest common factor. So how do you do that? Well, you could do a calculator, or you could do a multiplication chart. So if you have a multiplication chart, take it out right now. Let me get mine. Hold on a second. Okay, so here's my multiplication chart. If you need an extra copy, come ask Ms. Carranza or myself. We've got extras. So I'm looking for the multiplication, or the factors of 1 and 64. So the way we're going to write this is we're just going to take a line and we're going to draw it straight down. So what numbers multiply to 1 and 64? You might be able to name a couple, but they're always 1 and the number. So 1 and 64. And we're going to try to go in order. Well, does 2 go into 64? It's an even number. If I look across my chart right here, I'm trying to look 64, 64, 64. Oh, my chart's not big enough. So if you have a calculator, you can just take the number, well, 64 divided by 2. Okay, 32. So 2 and 32. Now, does 3 go into 64? Here's 3. I'm going to look all the way across, all the way across. Up, it gets close to it right here, but it's not there. So 3 doesn't. What about 4? Up there it is, 4 and 16. So 4, 16. So now we're going to look. Does 5 go into it? Does 6 go into it? Does 7 go into it? Does 8 go into it? Boom. And 8 does, and it's 8 times 8. So 8 and 8. And now's where we stop, because if we look, we start to repeat the numbers. Once we start to repeat the numbers, we know that we have found all of the factors. Okay, does that make sense? Let's do another one. So number 2 is 56, so 56, it's always 1 and 56. It's an even number, so 2 goes into it. 56 divided by 2 is 28. And now you can see, if you're going to do this on on your calculator, no, that's not even. Let's use the right number. 56 divided by 3. No. 56 divided by 4. Yes. Okay. So 4 and 14. You could have done the same thing by looking at 4. Here it is, 4 and 14. Okay? So does 5 go into it? No. Does 6 go into it? No. Does 7 go into it? Yes. It's 7. And it's 7 times 8. And now we've started the next number, so we know we're done. Okay? But now how would we do that with variables? X squared, well, what multiplies to get to x? Well, to get to the x squared. Well, that's x times x. That's it. Those are the factors. Okay? For m squared n3, we have 2m's times 3n's. And those would be the factors of what multiplies to get there. Okay? Now, there is a little shortcut. So when you're trying to find the GCF of variables, it's always the variable in common with the smallest exponents. So you're looking for things that are the same, but the smallest exponent. Okay? All right, next we have to find the GCF of the following monomials. And what we're going to do here is we're going to take the factors of 12 and do the factors of 42. Now, the key thing is we want the GCF. GCF means the greatest. So, let's go through. 12 is 1 and 12. This one, guys, you should know. 2 times 6 and 3 times 4. All right, so 42 is 1 and 42. I know it's 2. Let's look at the multiplication chart. 2 and there it is. 21. And see, we can't stop right here and be like, well, hey, Mr. Grice, 2 is a factor. Duh, but I want the greatest. We got to keep going. Okay, so does 3 go into it? Looking 3 and 42. Yep. 3 and 14. 4, nope. 5, nope. And 6 and 7. So the greatest number that they both have in common is, let's get a nice pretty color to circle this, 6. So the GCF is 6. And that's how you'd write your answer. Okay? So you do the factors of all of them and then just write them out. Okay? So the factors of 15, of 25, and 60. So the factors of 15, 1 and 15, 3 and 5. Of 25, it's 1 and 25, 5 and 5. 60, 60's got a lot. So 1 and 60. 2, 60 split in half is 30. 3, and guys, right here you should be using your multiplication charts to help you out. 3 and 20. 4. 4 and where's 60? There it is. 4 and 15. 5. 5 goes into it. It's 5 and there it is. 12. And 6 and 10. So the GCF, the highest number that all 3 of these have in common, is the number 5. So we would write the GCF is 5. So now we're doing it with numbers and variables. Some of you might be able to see it right away and be like, oh, it's this number. Good for you. But what we're going to do is we're going to write them out. Okay? So, of 8, 8 times 8, 2 times 4. To get to 12, we just did 12, so it's 1 and 12, 2 and 6, 3 and 4. Right. Oh, Mr. Grice, it's 2, it's 2, it's 2. No, it's not. You want the highest number. Okay? So, now that we got the highest number, we also have to worry about the exponents now. Okay? So, let's take a look at the exponents. They both have an m. Which one's smaller? 2. They both have an n. Which one's smaller? The 1. So what our GCF then would be, let's break this down. So the GCF we said the highest number was 4 m squared n. Okay, remember that we got the 4 from there, the m squared from there because it's the lowest, and the n from right there. Okay, let's try another one. So the first thing we have to do is look at the numbers. So 1 and 8, 2 and 4. 12. 1 and 12, 2 and 6, 3 and 4. 6. What numbers multiply to get to 6? 1 and 6, 2 and 3. So our GCF, the highest number that all of them have in common, is 2. Now, let's look at the variables, okay? This one has a W, this one has a W, and that has a W. So the smallest one is W squared. Now looking at the y's, the smallest y is that one. So when we write our GCF, it is 2W squared y. Okay, last two. Oh, we got a couple more. I'm sorry. I'm lying. Looking at 9, all we have to do is find the lowest number that they both have in common. Okay? They both have a y, and the lowest one is the y squared. Now I see a w here, or y there, but there's no y here. And I've got an m, but there's no m there, so those are not counted. The GCF is just going to be the w squared. All right, number 10, I want you to pause the video and see if you can figure it out. Now, if you're having trouble, I actually wrote this one out so you could see that, well, it's just going to be m, but then what about the n's? Well, we got 2 here, we got 2 here, and we got 2 there, so the GCF is actually mn squared. Okay? And I'm sorry for that last one. If you wanted to take a look at it, it's w times y and w times w times m. The only thing they have in common are those 2 w's. All right, number 11 and 12, I want you to do all by yourself. Okay? Good luck. Go ahead and pause the video. Okay, and there are the answers. Now for number 11, the only thing they have in common is the number 1. Okay? And then after that, you look at the lowest, or the variable that they both have in common, but the smallest exponent. Okay, and the same thing with 12. They all have x's, that's the lowest one, and they all have y's, but there's the lowest one, so that's where we get those numbers. So, your homework is the other side of this. If you have any questions, please come see Ms. Carranza or myself. Otherwise, that's going to be it for Algebra 1, Chapter 9.4 Notes, Greatest Common Factor, Day 1. Guys, thanks for watching.